Alright, so as requested, you guys want an explanation of that super hard lab. How dare I make you think without me there to walk you through it? So, yes, the lab was very confusing. It was supposed to be. However, you guys are completely capable of doing what I assigned. So, here is your setup. You have your cart on a track. Here's a ring stand with your force meter. It's, over here attached to the green box thing, which is then attached to your old laptop. Beautiful, I know. So, what do we do, Mr. Saslow? Well, here's what's going on. From here to here, you have a spring. What's going to happen is the spring is going to, when you let go, pull the cart. So it's going to roll towards here, and then you're going to catch it. All right. Now, meanwhile, what's going on is this thing, represented by the blue box, is recording how strong the spring force is. And it's going to make you a graph of that up here. All right, so what have we done? Here, and spring, let go, cart rolls here, catch it. What's happened on the screen? On the screen, what you should have is you should have a beautiful little graph, looks something like this, where this is force, and that's time. And it's gonna look something sort of kind of like that-ish. And then, it'll hit, and maybe it'll do something like that. Whatever the shape is, it'll have some shape that has an area under the curve. Ooh. Alright, so that's what's on this screen here. Meanwhile, what's happened here? It's gone from here to here. Alright, so it starts here. So, we know its mass is 500 kilograms, 500 grams. So 0.5 kilograms. And we know its initial velocity is 0 because it's not moving. Well, okay, we have here on our computer, we have force and time. So, oh, wait a second. We know that impulse is going to be force times time. You know what the time is. It's, whatever that is. Average force. How do you find that? That is the confusing part of this lab. What you got to do is you got to select this data on the laptop. So, click, drag your box around it. Then there's going to be a button called Stats or something like that. I forget exactly what it's called. And it'll tell you all sorts of interesting things, among them the average. All right, there you go. Done. So you have your average force for this trial. You have the time, which is whatever there to there is, for this trial. You can multiply them, you can get the impulse. All right, well, you have M and V naught. Oh, so wait, you can get P naught here, which is going to be M times V naught. All right. What are we testing again? Oh, that's right. We're testing the impulse momentum theorem, which states that the impulse should be equal to the change in momentum. So all we need, magically, is the final momentum. And then we can find the change in momentum and do a percent error between that and the impulse. Problem, how do I get the final momentum? Well, I already know the mass. It has not changed. I need to find some way of finding my final velocity. Alright, well, how do I do that? I haven't set up a motion detector which tells me the velocity, so I need some other way of estimating my velocity at the end. If you read the instructions, it says, so I want you to take how long it takes to travel the last 10 centimeters. That's your hint right there. I'm saying I want you to time how long it takes to travel the last 10 centimeters. I expect that you should be able to go from that to an estimated final velocity. All right, so what do? You set this up so there's a spring attached from here to here. You click go on the laptop, it starts recording, you let go. The spring pulls it here. At this point, you hit start on your stopwatch. And at this point, you hit stop on your stopwatch. You hit stop on the laptop. You get your funky little graph. From it, you get the force time and the average force, which gives you impulse. From the 10 centimeters and the time from the 10 centimeter line to the 0 centimeter line, you can get the final velocity. Final velocity gives you final momentum. Initial velocity gives you initial momentum. You're testing the impulse momentum theorem. All right. Which should leave you with average force times delta t. I'm going to put a little f there so you remember what delta t we're talking about. And that's going to equal m, v final minus v initial. All right, so notes. That's from the computer, and you had to click stats to get it. That's straight from the computer. That's known. This is 0 because it starts at rest. The only thing you have to worry about is this thing right here, which you estimated using this, where again, this delta t is not this delta t. It's a different delta t. Where this is 10 centimeters. Well, remember, I'm going to need to convert that to meters later. Over however many seconds it was. Delta t, and I'm going to write 10 centimeters. So I can keep them straight. Alright, so a number from the computer, a number from the computer, a number that Mr. Sazla gives me, a number that I should be able to figure out, and an estimated number. They should be equal. Now, they're not going to be. They're going to be close, or at least should be. But it's going to give you that and that. And then I want a percent error. Hopefully you remember how to do a percent error. If not, there are two ways of doing it. You can either do the percent deviation from the impulse, or you could do the percent deviation from the change in momentum. I do not care which you choose. So it could be that, or it could be that. It doesn't matter. They will be different numbers that tell you approximately the same thing. Done. All right, if you have any more questions, continue to post them in the share stuff place. All right, I hope that made sense. At this point, we are not going to continue to do the lab. You are going to take whatever numbers that you do have, and you are going to write me a conclusion. Now, if you haven't done enough of what you were supposed to do to write a real conclusion, then what you're going to do is you're going to write me a conclusion about what you did do as opposed to what you were supposed to do. So tell me here's what we learned, here's what we did, here's what we learned, here's what we were supposed to do. However, Mr. Coles told me that you guys did in fact get data, so you should be able to give me something closer to what I originally asked for. The big trouble that you guys are going to have is you might not have gotten an average force. In which case, guesstimate. And tell me that that's what you're doing. That, I don't know, the force is all over the place, and so I chose this force, and I called it average. And you know what? That's just fine. For this lab, that is just fine. Alright, that's all you get on lab stuff. Go ahead and get to work writing that conclusion. Go!